So today we're going to start talking about debugging. It's probably one of the most important skills that you can learn as a computer programmer because none of us write perfect code. Or if you do, you're exceptional and you break the rule. And so when we write our code, we're going to make mistakes, and so we need some way of figuring out where those mistakes are. So debugging, it's simply the art of figuring out why your program isn't working like you expect it to. It certainly is an art. It's not a science. There are some techniques you can apply to make your debugging process go a little bit faster, but it really requires that you just get more and more experience with it to be able to do it better. There are many different ways that you can debug. There's print debugging and log debugging, which are essentially the same thing, but print debugging prints to the screen and log debugging prints to a file. And then there's also using a debugger. How many of you guys do debugging of at least one of these three forms? Okay. For those of you that don't debug, does that mean you write perfect code? Or how do you end up figuring out what your problem is when you're running your program? Yeah.
I write my code in a really haphazard way.
You know what? So, haphazard, yeah.
So like it's I start by like thinking I need to get to this, and then I just start doing stuff. And like in the middle, if I'm getting the trace back, I like think like I have gone wrong, and I put like a print statement in there to see what the output is and see why it's not like working with the rest of the code.
What happens though when you're not getting an exception being thrown, but it's just not working right? So it completes, but it's just not doing the right thing.
Then I just like that's usually why I put the print statement in, because I might have like some data read wrong, and then my end result like is correct.
Yeah, so you do the print debugging.
But like it's not what I want. But if I have like a trace back, like I check to see if I forgot to convert something to English.
Yeah. Yeah, so it does sound like you do some print debugging in your programs, right? You print out the values when the things start to go wrong, right? Which is what print debugging is. I know, did you guys ever try the tried and true method of just looking really, really hard at it and yelling at it, why aren't you working? I've definitely done that one. It doesn't yield really good results, or even like the staring at it really hard tends not to work really well, because when we write our code, we tend to write code that we believe is correct, right? Most of you guys aren't going to spend time putting down code that you believe is wrong, right? So if you look at your code really hard and you're like, this code should be right, and you think it's right, and it's supposed to do the right thing, but it's doing something wrong, how are you going to catch your error? Just by looking at it more, because you believe you're right, even though you're seeing this contradictory statement that it's not working, right? So we need the debugger to kind of show us where we're doing something wrong. Where did we expect X to happen, but Y is happening instead? And finally have that like shoved in our faces here, like you thought this was supposed to happen, but this other thing is happening, to allow us to actually admit that, oh, oops, I did screw up. Let me go fix that now. Then once we figure out that, we realize we had this problem, we can go and think about how to fix it. So some advantages of using a debugger is that there's no need to add and remove those print statements. When I was using print debugging, which is totally where I started with when at the beginning of my programming career, I'd like put the print statements in to solve my bug, be like, great, fixed it, take it out. Oh, new bug, I need all those print statements back in. Put them back in, put them back out. Put them back in, put them back out. So it was a lot of extra work of like copying and pasting and deleting or commenting out code. And then things might look uglier because I just left all those like commented out print statements in there. So it's harder to read. I've also had it where when I went to write print statements, I introduced more bugs into my program. Especially true when I was writing C or C++ code, and caused more things to break. When you're using a debugger, you don't have to write any print statements, so you don't have to keep adding and removing things. You also won't cause any additional things to break your program by introducing new pieces of code. So there are a couple of things you have to satisfy before you can start debugging. The first and most important thing is you have to know what the right answer is. If you don't know what your code is supposed to produce, how do you know it's producing the wrong thing, right? You have to have some expectation of what's supposed to happen to compare it against what is happening and figure out how to, change reality to match your expectations. Don't change your expectations to match reality, right? The other thing that you have to know is what the process your code is supposed to be following to get the answer that you want, right? You have to know each step along the way what things are supposed to look like. Because if you don't know what these things are supposed to look like, how are you supposed to know when it does the wrong thing, right? So you really have to have a good understanding of what's supposed to happen before you can debug. You also have to have some inputs that cause problems, because none of us are going to debug our code when it works, right? We only debug it when it breaks. So it's really important to have good test cases that thoroughly exercise your code, and to really focus on making sure you hit the corner cases and edge cases, and that they're being tested by your program. So debugging is actually relatively simple process. You set breakpoints where you think things are going wrong, display the relevant variables that are going on in this piece of code, step through your code, see how it's executing what it's doing until you finally find an error, fix the error, and then you keep repeating until there are no more errors left in your code. So it's not very hard. If you want to set breakpoints, breakpoints are essentially points in your code where you want the program to pause. You just click to the left of it. So now when my program reaches those particular lines of code, it's going to stop there. And then we'll be allowed to inspect the state of our program. The compiler, I'll show you, or the debugger in a moment, will show you the values of the variables. And we'll get into what this problem actually is in a minute. This. So you can see here that letter 1 is being displayed, letter 2, its value is being displayed, word 1's being displayed, Joe's being displayed. You can also see the values up here as well next to the variable. So you can see word 1 is Bob, word 2 is Joe, letter 1 is B, letter 2 is J. No print statements, right? It's just automatically showing up. If I want to see something that's not being displayed there, it's fairly easy. So if you have some complicated, or not so complicated expression, one way of adding it is to highlight the expression that you're interested in, right click on it and say add to watches. And that value will now show up down there. This expression can be as complicated as you want. So, and it can have function calls. So maybe I want to see what's the length of word 1. Oh, it's 3 long, and the length of Bob, that makes sense. If I want to see something weird for whatever reason, I can say, well, I want to say the length of word 1 plus 5 times 17 minus 24. I don't know why you'd want to see that in this particular context, but the point is that your expressions that you write here can be arbitrarily complex. And you can see, pretty much whatever it is that you want to see without adding any print statements. Any questions so far before we jump into the code? So how many of you guys have done the anagram problem before? Do you guys know what anagrams are? So 2 words are anagrams if you can rearrange the letters in one word to form the other word. So some examples of anagrams are Mary and Army, because you can rearrange the letters in Mary to form Army, or painter and repaint. Those also happen to be anagrams because you're able to rearrange letters in painter to form repaint. Bob and bobcat are not anagrams because you cannot rearrange letters in Bob to form bobcat. Does that make sense of a definition of what anagrams are? Have any of you guys ever solved this in a program before? Okay. Those of you that have, please refrain from commenting on what the answer to this program should be so that we can continue with the learning process. So, I always recommend that when you get started with a new problem, and this is more on the problem-solving end than on the debugging end, that you do some examples. So we have some examples here of words that are anagrams and words that are not anagrams, right? So we know that Mary and Army are anagrams. How'd you figure that out? Yeah.
You can traverse both strings and then see, like you can map a dictionary to the values of the first string and see if they're in the second.
Yeah, so right now we might say that a possible solution might be, well, if every letter in the first word appears in the second word, then those 2 words might be anagrams. And that's what we're going to use as our working definition for right now. I also want to show you over here that I had some test cases. These are the things that we're running right now. You will see more on unit testing probably at the end of next week, and you should definitely be writing unit tests after I tell you how to do it so that you can test your code in a systematic way. Because I imagine a lot of times what you guys have been doing for testing up until now is like you'd always keep typing the input over and over and over again every time you wanted to test it, whatever that problem happened to be. It's much nicer if you already have the test cases and then after you make your changes, you're just like, oh, I'm going to rerun all my test cases and see if everything still works. So here we have some words that are anagrams. These are all anagrams of each other. And what we do is we go through each of these word pairs right here. So for word 1, word 2, and anagrams. And we create a subtest and we test that we get the value true back when we call our anagrams with word 1 as the first parameter and word 2 as the second parameter. Because yes, they're going to be anagrams because we're running through this list that are anagrams. And we also go the other way around too. Make sure that word 2 is also an anagram of word 1, just to make sure that we can catch any kind of like weird behavior our program might have. And then over here we print out some kind of error. Or if there is an error, we'll print out this additional message in addition to what unit test normally prints out. This is what's called a format string. It's new and it was introduced in Python 3.8. You start your string with an F, and then inside of the string, anything inside curly brackets, you can put a Python expression, and then Python will evaluate it and put it in that spot. So this will put like whatever the value of word 1 is, followed by the word and, followed by the value of word 2, followed by our actually anagrams. So it makes it really easy to format a string. If you've been using like dot format before, it's way better than using the dot format expression. And then we also basically have the same test, but with words that are not anagrams. And again, we just want to make sure that these words aren't anagrams, so we're asserting that they're false. Our main program back here, again, you can see that there's some basic examples of, again, using the format string. So again, the first word and the second word, and then I have another expression right here, and it will be R if the two words are anagrams. Otherwise, it'll be R not, followed by anagrams. So you can write an if statement as an expression, which we'll probably be talking about either on tomorrow or Friday. So here is our piece of code right now that we're testing. And so what we should first do is run it. So we'll just press run. And we're getting a lot of failures, right? So if we go into our test cases down here, we can see that we're passing all the test cases where the words aren't anagrams, but we're failing some of the test cases where the words are anagrams. This function is being called a lot of different times, but we should probably only focus on one particular failure. So what we can do is we can change our breakpoints to be conditional breakpoints by right-clicking on them and then adding some expression. So here, I only want to break here if word 1 is equal to Mary. And so now I'm only going to stop on this piece of code when this condition is satisfied. Otherwise, I'm not going to stop here. This can also be really useful in loops. Maybe you have some loop that runs, say, 1,000 times, but things only start to break after iteration, say, 600. It'd be very painful to have to go through each of those iterations all the way up to 600. So what you could do is you could put your breakpoint in there and then add a condition to it to say, only break if the iteration is greater than or equal to 600. And then fantastic, it's only going to stop then. You can write any valid Python expression there and it'll work. It's also really useful, like in this circumstance, is that we know our function's working correctly some of the times. It's working with all the false or all the words that aren't supposed to be anagrams. But it's failing on certain ones where our input is, for example, Mary and Army. So we can just say, hey, only break at this function when I know it fails with these inputs. Do you guys have any questions so far? We'll talk about the else statement in a moment, because it's actually paired with a for loop. I know, right? Weird. Do I need to turn down the lights at all? Does anybody want the lights off? Okay. So the way this works is, right, we said we're going to go through each letter in word 1, then we're going to go through each letter in word 2. If they match, they're going to break. Notice this else statement, it's paired with this for loop. So the way that else statements work when they're paired with loops is you end up entering the else statement if the loop finishes normally. So if the loop finishes normally, like we get all the way through all of the elements, we're going to enter the else statement. If we end up breaking out of the loop at all, we will not enter the else statement. Anybody need that said again? So again, you're only going to enter the else statement if the loop finishes normally. If you break out of the loop, you won't enter it. So here we're like, if we found a match, right, we're going to continue searching for the next, we're going to go to the next letter, right, of word 1 to see if it finds a match. But if we don't find a match, we're going to return false. So now let's try debugging it, which again, you press debug to run the debugger. So over here, right, we can see our letters. And we're probably really interested if whether the letters match or not. So over here, I have M and I have A. Do they equal each other? No. So we now need to go to our next line of code. When you're working here in the debugger, you have a couple of different options for moving. The options you have are step over, step into, step out of, and continue. You also have restart if you want to restart the program from the beginning. So what continue does is it will bring you to the next breakpoint that you would encounter in your program. So as your code executes, the next breakpoint that you would hit, it'll bring you to that one. So continue execution until the next breakpoint is reached. The step over and step into, they both do the current line of code that you're on. The way that they behave differently is if that line of code contains a function call. If that line of code contains a function call and you do step into, you go into the function and you continue debugging from inside that function. If you do step over, you'll step over the function and you'll do that entire line of code, that entire function will run, and you just move to the next line of code. Step out of runs the function to completion, and then you'll leave the function. So go back to where you were called from. Any questions on the differences between those methods of movement? Yeah.
Can you just repeat it one more time?
So yeah, they'll also be on the slides. So step over is, and step into both do the current line of code that you're on. But step into goes into functions, and step over goes over the function call. Continue to the next breakpoint, restart, restarts, and step out of means finish the function and go back to where you were called from. Yeah.
So if you did step into, that would mean like if you had a loop with multiple other things and you could only go through them.
So again, step into and step over only behave differently if the line of code that you're on contains a function call. And we'll see examples of it in a minute, but it's whether or not you want to go into that function or not. It doesn't control anything about the loops about whether you go into a loop or not, because a loop isn't a function call. Does that make sense? The other thing that I should mention that's really nice is down here you can see the stack trace, and this is showing you what functions were called to reach this function. So right now, test words that are anagrams called are anagrams, and we're right here at this point in time. This is really nice because sometimes some of your errors aren't actually in this piece of code, but they're in the calling code. And if you need to go back to the calling code and see what the arguments and the variables are here, you can just click on it and move back up the stack trace. And you can see what the values of these functions, the values of the variables up here are. This would be something that would be really hard to do if you're doing the print debugging, because you either print out the stuff or you don't. And if you realized, oh man, I should have printed out that variable from that function that called me, well, too bad. But here with the debugger, we can just click, we're back up to that function, and we can see the value. So M and A, they don't match. And again, you can either look down here, or you can look right here for the values of the variables. So they don't match, so I'm going to do step over. And so we go to the next iteration. So now we have M and R, again, don't match, so we don't go into it. And then we have M and M, they do match, right? So we end up going into the if statement, and then we break. So we break, which causes us to return false. But what's wrong here? What seems to be the error? Or like what's inconsistent about what our expectations are? What do we expect to have happen given that we just found a match? Yeah.
Instead of return false, it should have just went to the next letter in the first string.
Right. So we matched this letter, right? So our expectation is we should go and match the next letter, right? But instead we end up returning. Why do we end up returning false here? What's the problem? Or how can we fix it? Yeah.
Is it because that, from what I understood when we're comparing the letters, we compare, like, for Mary and Army, we compare the first letter in each word, and even if they are not the same letter?
So the way that this works is we take M and then compare it with A. Okay, no match. M compared with R, no match. M compared with N, match. Great, we found a match for the first letter of the second word. So let us move on to the second letter. Oh, A and A, great, match, right? R and A, no match. R and R, great match. So we can move on, and then Y, no match. Y, no match. Y, no match. Y, no. Y, finally get a match with Y. Great, we found matches for every single letter in the first word and the second word. So we're all cool, and so we say, yeah, these words are anagrams.
Because like you don't want it to return true after it exits the for loop, but so you put return false, but you should have incremented it to the next index of the word.
Yeah, we should have actually tried to go on, right? But so do you remember how I said how the for else statement kind of works, right? It's if the loop finishes normally, we go into the else statement.
Yeah.
But what is this code assuming?
The nested for loop doesn't it breaks out.
Well, I mean, it's kind of like assuming the opposite of how it's actually supposed to work.
Is it like breaking out after it finds something that's not matching?
It breaks out when we find a match, right? But it seems to be that the person that wrote this code got confused with how the for else statement worked. And they assumed if we break, we enter the else. Because if we found a match, you can see from their code that they want to continue searching, keep checking the next letters, right? But they've misused the for else statement. So how could we fix the code so that it ends up doing what we want? How can we change things?
Would you want to invent the else under the if?
Then the else would.
No. So like the if and else would match up.
So if we have the if and the else match up, right? Oops, cancel. This is basically saying, okay, if I have a match, break, and I'll still return false. Otherwise, if I have no match, just look at the next letter in the word. But it's not going to, basically, having the else statement here does nothing. Because we're saying basically else, go to the next iteration. But if there was no else, what would we do? Go to the next iteration. Right? Switch, continue, and break. So you want to switch this to be break here? Because then we'll just break out and we'll stop searching altogether just because we found a single match, which wouldn't be our intent. Or no match, we'd actually break out. Yeah? So you want to switch, continue, and break? It won't quite work out. So again, think about what we want to do. What's our goal? If we find a match, what should we do? Go on to the next one. And if we don't find a match? Well, if we don't find a match for this letter, what does this mean? They're not anagrams. So what can we safely do at that point? Right? So notice, I'll enter this else statement when? When I find no match for the letter, right? Because the only time I enter the else statement is if the for loop finishes all the way, right? So over here, what should this be? Return false, right? This should be a return false here. And then we could probably just get rid of that line, right? Because now if I find a match, I'll break, which means I'm not going to enter the else statement, and I'll go and I'll check the next letter, right? And if I end up getting through all the letters, never hitting this return false, I'll end up returning true. Yeah?
But if all the letters are matching, does that mean they're just the same word, not anagram?
Well, no, but I mean, army and army are anagrams because you can rearrange letters in the first word to form the second word, right?
Yeah.
But again, notice that if you look at Mary and army, every letter in Mary appears in army.
Yeah.
Right? But are they the same word?
No.
But they're anagrams, right?
Yeah.
So our logic here would hold for that. Or were you asking something different?
I think he was asking that if they're the exact same word, are they therefore
Yes, two words that are the same word are anagrams. You just don't really have to rearrange the letters at all. But we will treat the words that are identical as anagrams. Yeah.
We never run into a problem if we had a word which had two letters in the same.
So we've just made a change to our code. So what should we do?
Oh.
Test it, right?
Oh.
See if everything's still working. So let's go ahead, since we made this change, and let's see if our tests pass. So we now run the tests, and again, things are now failing. But notice that now we're getting all the words that are anagrams. We're able to correctly identify them. But we're having some problems with words that aren't anagrams. So we're able to correctly identify that Bob and Joe, they're not anagrams. But we have this word like Pepsi and Pepsis. We think they are anagrams. I think it was about the point that you're bringing up, right? It's because every letter in Pepsi appears in Pepsis, right? So we have that problem. So right now our solution isn't correct. I just wanted to show you that here, right, everything looked sort of right, but again, the comments were also somewhat misleading, so be careful with that. Here's the version. Boop. If we found a match, right, just go out, oh, return false, we didn't locate a match, and we found a match for every letter. So how might we resolve this problem with Pepsi and Pepsis? Yeah, each word needs to have the same number of letters. So we can go ahead and add that in right now. So if the words don't have the same length, return false, right? So we've made some change to our code, so what should we do now? Test it, right? Which this is why it's really nice to have these test cases pre-written, because I don't have to keep typing every single time the same thing over and over and over again. So over here, when we add this, we are passing now the Pepsi and Pepsi's test cases. That's fine, but we're still failing some of them. We're still failing app and ape and AAB and ABC, right? Mm-hmm.
Could you just like instead of returning to actually just map the letters from the second word back?
So you want to see if every letter in the first word appears in the second and every letter in the second appears in the first?
I mean, that would be tedious, but like.
Oh, it's not. I'll show you. Right? Because now notice that our solution to the problem is if every letter in the first word appears in the second and every letter in the second appears in the first, these two words are anagrams, right? And we should try to write our solution that way. I do also want to just demonstrate like how we could kind of see where this thing starts to go wrong. So we kind of want to break here if word 1 is equal to app. So we then run it through the debugger. And we're going through and we're like, okay, so notice, probably should have moved that down a little bit. So now we have both A and A, right? So yeah, hey, we have that match A here, A here. Then we go to our next letter P, and well, P doesn't match with A. So we go to the next iteration. Ah, this P matches with that P. So then we go around again. The first P doesn't match with A. Now the P matches, with this P, oops, and so that's why we have the mistake. So now let's make the suggested change to make sure that we do a symmetric check. Oops, wrong thing. So over here, right, we said in our solution that if all the letters in word 1 are contained in word 2, and all the letters in word 2 are contained in word 1, and we probably still need that same check that they're also the same length because otherwise we get screwed by Pepsi and Pepsis. Again, we're going to have that there. But notice if you don't focus on this for a moment, but just focus down here, that how does our code read? Well, we say the length of word 1 is equal to the length of word 2 and contains all the letters in word 1 are contained in word 2 and contains everything in word 2 is contained in word 1. But it reads very nicely at least for the most part, if we kind of understand how the function is supposed to be read, what should happen? What allowed this magic to happen? How did it become easy to read? Yeah.
Like instead of rewriting the whole part again, you just plug in, you just reverse the variables that you pass through and as parameters. So it's like.
But we passed the parameters to
Separate
function, right? We had to break down our new subproblem, right? Our definition for whether two words or anagrams became if the words are the same length and all the letters in word 1 appear in word 2 and all the letters in word 2 appear in word 1. So notice that appearing, right, or contains kind of check is a somewhat decent sized step in our solution, right? It's not something that we can write very easily, which is I think what you're getting about earlier about it being tedious to do the symmetric checking. But even if it wasn't tedious, it's still a good idea to break it out into another function so that it reads easily, right? You could probably read that code and have a pretty good idea of what it's doing, even without comments there, right? And if you're a little bit familiar with the code base, even easier, right? So I highly recommend that when you're doing your solutions, which start with some examples, write out what you want to do. I've just been saying it because I write slow and we don't have much time. And then once you've written it, test to see whether it works. We're kind of doing that right now. And then go and translate it into code. Again, big parts of your program should become functions in your solution. This might seem like it takes more work than just jumping straight in and programming, but it'll actually take you less time because you've solved the problem in a principled way. And one of the big things about like solving the problem on a board or on a piece of paper is you're not stuck thinking in code, right? If I ever ask you to make a change here and you're looking at the code, what are you thinking in? Code. And it's really limiting in terms of your thought process when you think in for loops and if statements and while loops versus saying this is what should happen. When you're able to say this is what should happen, it'll just flow. Trust me. It'll be a lot easier. So do try to practice this on your own. Now over here we have contains all. And we're going to talk about this. We'll also see this again in class coming up this week. So we want to check that all the values, or for each value in values, that it appears in the container. But all the values in vals, right, because again we're iterating over here, need to appear within container. Right, this is what's called a generator expression. It basically allows us to go through each of these values and it will consume them only as it needs it, and it'll only produce the value as it needs it. So all will stop checking as soon as any of the elements from this generator expression return false. An alternative way of writing this would be as follows, right? So we need to go through each of the elements in values. So for val in values, this should probably be for val, not vowels. So for each val in values, right? Well, when would we know that they don't contain all the elements? Right? So we're checking this letter, and what does this letter need to do in container? What's it need to be? So again, we're trying to see if all the elements in values appear inside of container. So what should we check about val? If it's in the container, what do you know? What can you say? Do you have an answer? We know that it's true, but like the first element appears in the value, or the first element in values appears in the container. Great, we know it, but we still have to check the rest. But what about the opposite? What if that element wasn't in values?
Could you break values apart and see if the values is equal to your other thing?
Well, we're doing that, right? We're trying to see if value is in values, or if value is in container, we have to check the rest of the values, right? The remaining ones. But if val is not in the container, will all of the elements in values appear in container? No. So what can we do? Return false. So we can say if val is not in container, we can return false. Now, when will we know when all of the values have actually appeared inside a container? Once the for loop finishes, right? because we'll only have checked all the values after we've gone through all the values, and we'll only have gone through all the values after the for loop finishes, right? So down here we could return true. And this piece of code and this piece of code, they both do the same thing. Who likes option 1, the top one, better? It's easier for you to understand. Who likes option 2? It's easier for you to understand. Fair enough. Probably because option 2 is new. Yeah.
Where is values in container? Like the simple, like where
Okay, so here's values as our argument.
Okay.
Right? So for each val and values, is that what you're asking about?
Yeah, like what is values? Is it just like numbers you type in?
So here, right, this function is just going to check, right? So we can add a comment here. You know, checks whether all values appear in container.
Well, like, what's the values and what's the container?
Does it matter?
Okay, so.
Right, because this is like a generic function. We just want to see if all these things appear in that other thing, right? But here, if you look at the type hints, what did we say that values has to be? Iterable. We have to be able to iterate through it, right? Because I iterate through it. And container needs to be a container, and containers support the in keyword, the in check, right? But because I didn't do the square brackets to say what the types are, the types default to any, so it could be anything, right? As long as I'm able to check whether this thing appears in something else, so as long as I'm able to iterate through the first thing and able to do an in check on the second thing, it doesn't really matter. It's a generic function, so this can check if, you know, some strings appear in a list of strings, or it can check if some character appears in a string, or some number appears in, all these numbers appear in this dictionary of numbers, right? Completely generic in that manner. Yeah.
Can you show like the function call for contains all? It's like, you know how there's like the main body code where you
Yeah.
like, do you have an example where you like you can see what's passed through?
Yeah, we're gonna do that right now.
Okay.
So over here, contains all. So I'm going to comment this out. A shortcut you can do in C-Line is you can highlight the code and do Control/, it just comments it all out. If you want it back, Control/ again. So we might say set a breakpoint. First, let's run our code to see if this works. And all of our test cases passed, right? So we'll just set a generic breakpoint here. So set a breakpoint on this line and then run the debugger. Now let's say we do want to go into this function and see what's happening, right? So right now, word 1 is Bob and word 2 is Joe. So if I do step into, I'm going to go into that function, and now I'll be able to step through this function one at a time because that line of code contained a function call. So here we can see that we could say that values is Bob and container is Joe. So we're trying to see if every letter of Bob appears inside of Joe. So we try to see, well, does my B of Bob appear inside Joe? No. So we return false, and we leave. If we do step over on this next line of code, we don't go into the function. We just go completely past it. And then we come back to where we're called from. Is that what you're looking to see? Or something else?
Yeah, no, like, yeah.
So our code passes all the test cases. Is it correct? Yes, it is correct. No, it's still wrong. For those of you that say, yes, it's correct, why do you say it's correct? All the test cases pass, right? But does that guarantee that your code is actually right? No. For those of you that say no, why doesn't it work?
It wouldn't work because the user could input 2 words and one of the word has a capital letter, and then it wouldn't work because the capital letter isn't equal to the lowercase letter, but like you know it is.
Yeah, so right now, one example that we have of failure is we don't work with different cases, right? But we should probably work if the M in Mary was capital, right? We should probably be happy with that, right? But just because we pass all the test cases does not mean your code is right, right? So you really need to have like really good test cases. Notice everything over here is lowercase, but we might go and add in a new example. And now we have, oops, I forgot my comma. There we go. And boom, we're back to failing again. So what could we do to fix this problem? Yeah.
Just add a line where we make everything lowercase or everything uppercase.
Yeah, make everything lowercase or everything uppercase. So we might decide to say that here we just say like word1 equals word1 dot lower, and word2 is equal to word2 dot lower. And then, bam, we're back to passing all the test cases. Now, is this code correct? Yes, it is correct. No, it's wrong. Okay, if it's wrong, why do you think it's wrong?
You saw a mechanical and auto fringe cases, I guess.
Give me an example of a fringe case. Give me something that breaks my code. Because if you can give me a counterexample, like your code doesn't work for this, right, you're able to say I'm wrong.
Let's say you have like periods in there or something.
I mean, if they had an equal amount of, you know, the period, if one had periods and the other one had periods, right, we'd still be fine. We wouldn't really care.
You didn't like, I mean, you didn't like count that the input was on these characters, like they could have been.
Again, we don't really care, right? We'll just treat those, like if they enter like 1, 2, 3, 4, we'll just treat it as a string made up of the characters 1, 2, 3, 4, not the number 1,234. So that won't cause us any problems at all either. Any other thoughts?
The user could put spaces before or after when they're typing their input in, and if they don't put it in the second one, that would be messed.
So yes, we could deal stuff with like user, like, you know, handling what we consider to be incorrect user input, but I'm not looking for that. What about, I guess I can do it here. What about, again, we don't really care about white spaces. They both look, the strings had equal amounts of like, you know, white space, fine, they're anagrams. Right? What happens if we had something like this? You know, AAB and BBA. Are those words anagrams? But apparently we think they are. Right? We're failing that test case down here. AAB and BBA aren't anagrams. Fairly obvious to us. But our code thinks they're anagrams. Why? Yeah.
Because they're the same length, and you can find you can find both letters in both of them. So you basically will need to count how many letters per word there are and see if it's the same amount of letters in each word.
Exactly right. So this solution doesn't work because all the letters in the first string appear in the second string. All the letters in the second string appear in the first string. They're both the same lengths. Doesn't make them anagrams. So what we have to do is count how many of each letter appear in each string. And if they have the same counts of each letter, they gotta be anagrams of each other. Right? So over here, let me undo this stuff so I can switch back to my other one. So here's an answer. That'll work. So again, hold off on this. So over here, we made sure to lowercase. So we get the counts of word 1. So we get the counts of each letter in word 1. We get the counts of each letter in word 2. And then we check that they're equal to each other. Which is what we said to do, right? But notice that the code reads in our intention, right? Right? You want your code to read like you think, right? So again, a lot of functions help out here. Any questions about this code before we actually look at get counts? Yeah.
What does that hashable mean?
Hashable means it has the hash function, and to be a key in a dictionary, you have to be hashable. So basically, it's just saying, if you give me something that can, if you give me a list of things that I can actually use as keys, we're good. And then we're going to give back a dictionary of some hashable things, so we really weren't sure what they were. And then we're going to give back an integer, right? Because we're going to get counts. So a dictionary that maps each of the elements to their count. So here's what we do. So we start counts as the empty dictionary. Then we go through each of the items and items. And our count at that, for the count for that item is equal to, well, get what its current count is and then add 1 to it. But if this element doesn't appear inside of the item, its default should be 0, right? So the first time we find it, it ends up being a count of 1. Next time, 2, 3, 4, 5, so on. Every time we see the letter. Yeah.
Will that run fine if we don't put the default?
It will not run fine if you don't put the default, because the default will default to none, and then you'll do none plus 1, and none plus 1 is not like supported, and then you'll get an exception. Right? And so we can go over here and we can add in our test case that we had before. And we can do, what do we do? AAB and BBA. And you know, if we want to be like really cool, we can like put some random capitalization in there. Right? And again, we pass the test case. Any questions here?
Could you, instead of doing all of the previous steps, can you just do word count and have that check if they're anagrams?
Oh gosh.
Or sorry, letter count and have that check if they're anagrams? If they have all the same letters, should they be anagrams?
If they have, well, if they had the same, if they had the same count of each letter,
right,
then yes, they're anagrams.
Okay. Could you do that instead of
doing that for loop? I'm just not familiar with the function that you're referencing, so I didn't do it.
okay.
So maybe if it does the equivalent, then yes. So one other thing I want to point out as a solution is if you were unaware of this ASCII table, each letter can be considered to have a numerical value. For example, the letter A could be considered to have the numerical value 97, B 98, C 99, uppercase A 65, and so on. So solutions I've gotten to the past in this problem is 2 words are anagrams if the sum of their letters are equal. Right? So we might say, for example, here's my string like Bob, and then here we have ob, and maybe I want to change this to an A, and let's say A's have the value 0, just for simplicity's sake, and B's have the value 1. So over here we have 1, 0, 1, which is 2. Here we have 0, 1, 1, which is 2. Their counts are the same, so these words would be considered anagrams. Now, is this solution correct? Yes. No. For those of you that say no, can you provide me with a counterexample?
The uppercase letters versus the lowercase.
Again, let's assume that we still lowercased everything to begin with. Yeah. Or was it the same idea?
If it was uppercase, it would be passable because uppercase letters have a different value.
Yeah, so again, the idea that we can resolve that problem again just by lowercasing everything like we started out with. So lowercase everything and then sum up the letters. Yeah.
Can you different sum if you have different combinations of different letters can get you the same sum?
Give me an example.
Like if you had like I guess A, B, C are your 3 letters, and A is 1, B is 2, C is 3. You could do
Something like this. A, C, right? That's 0, 0, 2.
Yeah. And
then here we could do, A, B, B, 0, 1, 1. 2, 2. Are they equal to each other? I mean, yes, those numbers are equal to each other, but are they anagrams of each other? No, so our solution would fail. But again, if we go back and we use the test cases that we originally had, because I do have that solution, you will find that it would pass all those test cases. So if we go to some words version, which again, we sum up, ORD gives you the numerical value of the letter, we add them all together, we check if they're equal to each other. This passes all the original test cases. So one of the things I really want you to take away from this is that you need to have good test cases. They are the unsung hero of debugging, right? Those test cases are what allow you to find errors, and you really need to exercise the code. Just bear with me for one more minute, and then I'll let you go. One other thing that I wanted to point out is maybe you weren't sure where the bug was in your program. You generally have a good idea. So let's say this is our program. What we could do is set a breakpoint halfway through the execution point. And then if we get to that halfway point, we can look at the state of our program. And if everything is good, where does it mean the bug must be at? The second half, right? But if we find that something's wrong, there must be at least a bug in the first half. And again, if we find that there's something bad in the first half, we can set another breakpoint halfway down, right? And then continue debugging. Now, my hand example makes it look very easily, but how often has the halfway point of your execution been halfway down your file? Probably never, right? So you have to know what the halfway execution point of your program is to set the breakpoint there. Again, sometimes you should always be suspicious until you've tested it, and even then still be a little bit suspicious of it, of whether it's working correctly. Also, where you find the problem might not actually be where the error is. Sometimes your parameters are wrong, or sometimes there was some other error that actually propagated down to where you found it. So do make sure you check things that are coming up. And finally, I'm not willing to debug your code unless you're willing to debug your code. So if you come into office hours and you're just like, my code doesn't work, period, I'll be like, yeah, it doesn't, and I'm going to ask you why. So you need to run the debugger on your code to be able to figure out why it's not working. So you can tell me, like, my code's not working, here's what's happening, here's why I think it's happening, right? And I think it's kind of happening over here, right? You don't have to be right. You just have to have some kind of guesstimate or like intuition and looked at your code to know what's going wrong, right? If you just need help debugging, period, like you still need help about like how do I set breakpoints again, or how do I like, step over, step into work, more than happy to explain that to you all over again and help you work through it so that you understand how to use the tool and can actually use it. If you do devote some time to learning how to use the debugger, you will save yourself literally hours of work in this class. And hours of work in all of your other classes that involve programming. Because until you write perfect code, you're going to need to spend time debugging. And the faster you get at debugging, the faster you can move on and get the right program. See you guys in class tomorrow.